Welcome to this quick demo of OpenFiscal. OpenFiscal is a self-contained reimagination of open spending. It allows you to upload data and get an API that is fully compatible with open spending. It doesn't have any visual aspects, so it's mainly used for users who only need the API. For this demo, we'll use some mock data that looks similar to a very simplified budget of a country. We have here a Google spreadsheet with 2 years, 2019, 2020, with 4 departments. Each one has an approved executed budget and a made-up column that says, it's called funded by aid funds. So we'll try to load this data into OpenFiscal and see how it works. So when opening OpenFiscal, you need to log into the system. We use Google authentication. So we log into OpenFiscal. First thing we need to do is create a taxonomy. Taxonomy is basically the structure of the budget files that we want to upload. Usually we'll have multiple budget files for the same domain. It could be different districts of the same country or different years or both. So we need to define the taxonomy. In our case, we have already built in the generic fiscal data package, which is not to be used, but it should be used as a reference for specific taxonomies. So we'll go to the demo taxonomy and we'll start adding concepts to it. So the first thing we need to do is add the fiscal year. This is the first column that we need. So we'll go here and find the fiscal year. Then we want to find the department, which is basically the administrative classification. Next up is the budget. Budget is the amount column. And finally, we have different kinds of budgets, the approved and executed column. So we need an amount type. Then we want to add a new column, which would be funded by aid funds. So let's give it a name, funded by aid funds. And let's give it a nicer title. This is a Boolean, so we'll change the type here to be a Boolean. Okay. Okay, we can define here whether fields are required or not. In our case, it doesn't really matter because we have most of the we have exactly the same structure for both years, and we don't have any label columns. But in many cases, you'd like to mark the IDs as required and the labels as non-required. Okay. So now we've finished setting up the taxonomy. We go and create a new processing task. So we'll call this processing task demo 2019 because this is the first sheet that we're going to pull. We can give here all kind of metadata, geographical scope, etc., etc. All this is configurable, obviously. We'll call this dataset demo 2019. Sorry, demo. And we'll go to the Workbench. So this platform, OpenFiscal, can pull data from various sources, Google spreadsheets, CSVs, Excel files. It can even pull tables from HTML. If you don't have the data hosted, you can go to the source data and upload a file. But currently, we'll just use the link to the Google spreadsheet. and we'll let the data process a bit. Data is now being loaded to the server. And we need to choose the taxonomy. So we'll use the demo taxonomy. And now we can see that we have the data here. It's already been loaded, department approved, executed, etc. We need to now map the columns to those taxonomy columns. So we'll go and start. So first of all, administrative classification, this is the department. And funded by aid funds, it automatically detected that it's funded by aid fund because it has the same title. The date is a bit, oh, I see that I took the 2020 here by mistake, so let's go and do the 2019 instead. Okay. So the date is basically, it's not part of the data. It's only a constant. So what we're going to do is just choose here constant and say this is 2019. Okay. Now we need to say that this is an amount, but the problem is that this table is pivoted. We have the value type here as headers, and the value is basically in two different columns. So what we're going to do is say that the amount is an unpivoting value, and amount kind is an additional column for unpivoting. And what this does is basically creates this table here that allows me to specify for approved that amount kind is approved, and amount for executed that amount kind is executed. So now what happens is as follows. We can see here the original data. The map data is now unpivoted. So we have two rows for each one of the original rows, one for the approved value and one for the executed value. Finally, we want to work with this funded by aid funds. We said it was Boolean, but you can see that it's marked as red because it cannot understand the no and yes values. So we need to give the actual true values here, yes and no. And then it automatically knows how to parse the data and transform it. And now we can just save this. If I trigger the task after saving, then it will take the data and load it into a database. And indeed, the task succeeded, and we can see the entire execution logs. In the end, we can even see a bit sample of the data that was written. It's important to notice that the data is written in a normalized way so that queries are optimized and it's not just a flat table in the database. So now we're going to go and basically repeat the task for the other sheet here. So I'm going to go and do the 2020 sheet. So basically we're going to go and create a new processing task. Let's call this demo 2020. I'm going to go and save and go to the Workbench, put in the URL here. And again, data is loading. This time mapping will be shorter because it already remembers the mapping from before. So it knows how to map some of the columns automatically. It automatically detects the correct taxonomy. Again, we'll use a constant here and use 2020 as the constant value for the year. And we'll do the unpivoting configuration. And finally, here the true values. Again, we need to rewrite them. and we get success. We can again save and trigger the task. And after a few seconds, data is loaded into the database. Pretty much the same way. If we go to the processing task, we now see we got an eye icon, which basically connects us to the API. So here we're going to go to the API. And we get the Babbage API. We have the entire description of the API here, and we can even do an aggregate query, right, which gives us the sum of all values, drill down according to the year. This is the name of the field. And we get the sum in 2019, the sum in 2020. If you already know Babbage, then this should be pretty simple. And that's about it. Obviously, all of this can be configured, the metadata fields, the taxonomies, and even if you need some processing task to be done after data is loaded, then you can create Python files inside the Docker image that handle specific taxonomies processing. If you need some special data handling or column mangling or whatever, it's pretty easy to do. So that's about it. Thank you.